Hello and welcome to this video brought to you by Smart Exam Resources. In today's video, I shall explain to you the electrolysis of molten sodium chloride. As you can see on the screen, there is an electrolytic cell containing sodium chloride. There is a power supply that is intended to help in the process of electrolysis by supplying electrons, and inside the electrolyte there are mobile ions. So always remember, for a complete electrolytic cell you need the electrons to flow in the external wires and the ions to flow inside the electrolyte. Okay, so therefore even a solid ionic compound will never conduct, but a molten ionic compound will definitely conduct, because a solid ionic compound does not have mobile electrons. Okay, as you can see, there are two electrodes. One is called as the cathode, the other is called as the anode. Now, anode is a positive electrode, cathode is a negative electrode. Anode is a positive electrode because it is connected to the positive terminal of the power supply, and cathode is a negative electrode because it is connected to the negative terminal of the power supply. Okay. Another thing to remember is oxidation always occurs at the anode and reduction always occurs at the cathode. Okay. Oxidation is loss of electrons, reduction is gain of electrons. If you remember oil rig, you'll never forget this, right? Okay. Now, one more thing about the ionic compound is, even if you take solid sodium chloride, it's not going to conduct electricity. Why? Because the ions are not free to move in the electrolyte. So it is very important that the ionic compound is having ions which are mobile, right? Okay. Now what happens as time progresses? There are certain changes that are seen in the electrolytic cell. And yes, as you can see, all the negative chloride ions have got attracted to the positive electrode, and all the positive ions have got attracted to the negative electrode. That's based on the concept of opposites attract. Okay, fine. Now, what do you find after some time? Basically, what I'm showing you on the screen right now, that the ions are attracted to the anode and the sodium, in case of the negative ions, the chloride ions at the anode and positive ions at the cathode. You cannot see these ions. What you can see is something else that I'm going to show you on the screen. This is just an intermediate step that I've shown you as a part of the explanation. Now, what you can actually see in the laboratory is what's going to follow. So what you find is that there's a greenish yellow gas which is observed at the anode, and there are silvery white deposits at the cathode. So if you know that you are electrolyzing sodium chloride, you'll be definitely sure about the products. You will say that the metal is the sodium metal and the gas is the chlorine gas. Obviously, you need to conduct it in a fume cupboard because that is a very poisonous gas. Okay. Now, what are the processes that are happening in the electrolytic cell that are creating these kind of products? So let's try and understand the processes. To begin understanding, I have just taken one electron, although you know there are n number of electrons and there are so many sodium ions also in the electrolyte as well as the chloride ions. But I'm trying to explain to you one half reaction at a time, and therefore I've just taken one sodium ion and one electron, right? So now that you know that the positive ions are attracted to the negative electrode, so you'll have Na plus ions getting attracted to the cathode, which is the negative electrode. At the same time, I've already told you there are electrons flowing in the external circuit. And one more thing to remember is, you must have heard about the word conventional current. Now, conventional current is a current that always flows from the positive terminal of the power supply to the negative. But the flow of electrons is always from the negative terminal. So you will find that the electrons are leaving the negative terminal and getting into the cathode. So see what happens when that electron, see, I have not written E minus there, but I hope you assume that E stands for E minus. Okay, but because you know electrons are E minus. Okay, fine. So now observe carefully what happens when sodium ion receives that electron. So sodium ions have traveled to the cathode, and there are electrons which are leaving the negative terminal of the power supply and getting into the cathode. So this is the reaction that will take place at the cathode. You have the sodium ion accepting that electron and changing itself into a sodium atom, and that is nothing but the sodium metal that you can see at the cathode. And after that you're supposed to write a half reaction. A half reaction is a reaction, or a half equation is an equation that is representing what is exactly happening at one of the electrodes. Now since we are talking about the cathode, I'm going to give you a half equation for the cathode. Well, the half equation is Na plus E minus gives you Na. Fine. Now let's understand what happens at the anode that created the Cl2 gas or the chlorine gas. Okay, I'm beginning with one chloride ion, and you know chloride ions are negatively charged, they are Cl minus. So when they are attracted to the positive electrode, which is the anode, they are going to lose an electron. Again, E is E minus, so they are going to lose an electron and form a chlorine atom. Okay, now what is the formula for the chlorine gas? It's Cl2. That means chlorine gas is diatomic, so obviously the gas must be having two chlorine atoms bonded covalently. Okay, so now that means what comes out, the greenish yellow gas that comes out, is actually the Cl2 gas. Now to form that Cl2 gas, another Cl has to bond with this existing Cl. So I'm going to write one more equation for that Cl formation. So there are in fact two chloride ions losing two electrons in all to form two chlorine atoms. So if I write the half equation, it would be 2Cl minus 2E minus gives you Cl2. I've not written the states. You please have to write down the states. I'm just explaining without the state equation throughout the explanation. Okay, so now this is what is happening at the positive electrode. Okay, and you've seen what happened at the negative electrode also. So there are some generalizations that you can always make when you are electrolyzing any kind of molten ionic compound. So here are some generalizations that are going to help you from the exam point of view. First, non-metals are always formed at the anode. Remember, anode is a positive electrode and non-metals are formed because the non-metallic ions are negatively charged ions. Okay, metals are always formed at the cathode because metal ions have a positive charge, and positive charged ions are always attracted to the negative electrode, which is the cathode. The third point is oxidation always happens at the anode, reduction always happens at the cathode is the fourth point. The fifth is electrons flow in the external circuit from the negative terminal into the cathode. Remember, these are all important things you might be asked in the MCQs or anyway, even the theory paper for that matter, or the ATP, who knows. Okay, and electrons, when I say they, it means electrons flow into the cathode and they flow out of the anode. Okay, fine. So well, this is all on electrolysis of molten sodium chloride, and along with that I've also given you generalizations for the electrolysis of any given molten ionic compound. Fine. So well, that's all in today's video, and if you like watching my video, please do subscribe to my channel. Thank you.